Good morning, students. Today I am going to deliver lecture on the torque experienced by a current carrying rectangular coil placed in the uniform magnetic field. First of all, we draw the diagram. PQRS is a rectangular coil placed in the uniform magnetic field represented by the parallel lines. Length of coil is L, breadth of coil is B. Now, what are the forces acting on the different arms? Say F1 forces acting on PS arm, F2 QR, F3 PQ, and F4 RS arm. Let the current flowing in the anti-clockwise fashion. Now, what is the force acting on the PS current element? Why I have said the current element? Because the product of current flowing I and length of this PS line element B, so we call it current element. So current element is I into B. So what is the force acting between this PS current element and the magnetic field? We know the standard formula, that is IL B sin theta. Here L is replaced by B, so we write I B sin. Now what is theta? Here theta we are taking between this current element PS and magnetic field. So this is 90 degree. So what is angle between this PS and B? This is 90 plus theta. So this becomes IB sin, no, sin is sin 90 plus theta becomes cos theta. So it's cos theta. So F1 is IB cos theta. Similarly, what is F2? What is F2? This is the force acting between this QR element and magnetic field. So this angle is theta, but we have to find this angle. This is 90 minus theta. So this again IB sin 90 minus theta. So this becomes again IB cos theta. Now from this equation and this equation, it is very clear that F1 and F2, they are equal in magnitude, opposite in direction, and acting along the same line of force. So they are not contributing to produce any torque. So no torque is experienced by the coil due to these forces. Now what about F3? Force on PQ conductor, that is I, length of conductor is L. So this is ILB sin theta. Here theta, that is angle between this current element and magnetic field, is 90 degree. So we take it 90 degree. So F3 is ILB. Similarly, F4 is ILB because length of this conductor is also L. So this again theta is 90 degree. So F4 is equal to ILB. Now from these equations, it is very clear that, sorry, it is very clear that from 3 and 4 both forces are equal and opposite, but here the difference is they are acting along the different lines of action. Here we can represent like this. Say this is F4, this is F3, this is we have had written PS, this is B. So the line of action of F3 is this and the line of action of F4 is this. So they are acting along different lines of action, so they produce torque. So here theta, say this is perpendicular drawn. Now what is torque? The formula of torque is magnitude of either force, whether it is F3 or F4, both are same, and perpendicular distance. Now what is perpendicular distance? This is Pn. So Pn, we have to find Pn. How do we find? Say triangle PSN. What is sine theta? Pn perpendicular upon hypotenuse, that is PS. So Pn is equal to PS sine theta. What is PS? B sine theta. Now you can put here I L B B sine theta. So this you can write I L B sine theta. This is B, this is area, so you can write it I A sine theta. So this for n turns you can write it I is equal to, sorry, torque is equal to NIA sine theta. So this is NIA B sine theta. So this is the torque, equation for torque placed in the uniform magnetic field.